Hello, everyone, and welcome to NeuroAbility's Industry Vignette. My name is Cassandra Spiro, and I'm the NeuroAbility's Program Manager at G3ICT, which stands for the Global Initiative for Inclusive Information Communication Technologies. NeuroAbilities is G3ICT's newest program to explore the current state of assistive solutions based on advanced devices with a brain-computer interface component or an artificial intelligence component. And these often enable those with disabilities and older persons to better interact with their environment. I have the privilege of speaking today with Walid Sassou, President of Wearable Sensing, and he is also one of our NeuroAbility's Advisory Council members. He is also CEO of Quasar, which stands for Quantum Applied Science and Research. Welcome, Walid.
Hi, Cassandra. Thank you very much for inviting me.
Thank you. We really appreciate your time, and thank you for being an advisory council member. For some of our viewers, I'm going to get straight into the first question. For some of our viewers who might be still learning about how, I'm going to start using an acronym for brain-computer interfaces here. I'm going to say BCI. For some of our viewers who might still be getting familiar with neurotechnology and brain-computer interfaces, please tell us a little bit about wearable sensing and its role within a BCI system and the BCI world.
Sure, thanks. So BCI is usually a combination of technologies that involve monitoring the brain activity of a person and transforming the brain signals that they get into some command that can then be forwarded onto a computer or a robot or a machine to control that device with the thoughts of the person. So one element of that BCI is therefore some device to measure the signals of the brain. Wearable Sensing manufactures such a device. It's called an electroencephalogram, and that's typically called EEG. So what's unique about our technology is we licensed technology from Quasar, which had developed these dry electrodes. A dry electrode is a type of sensor that we can use in a non-invasive fashion to measure EEG signals. So typically when you need to measure EEG, you have to shave your head like me. No, you have to abrade the skin, which means you rub the dead cell layers, you put some gel, and it's a little messy of a system, but it gives good signals. And that's been used in research labs and medical facilities for years. To transition to a brain-computer interface that can be used in the homes and for people who might need to use it extensively for long periods of time, you need a dry electrode. And this is so the tool that goes in without the gel, without the skin abrasion, and we have it put into wearable headsets that put the sensors at the right locations above the right brain areas, give us the same high quality signals, that are immune to movements and motion and environmental artifacts, and yet provide the data to the computer algorithms that can then decode it and do some control. So what fit into the BCI space? So this is just one component, and then it fits in interfaces with software like the software developed by the Wadsworth Center. It's called BCI 2000 or BCI 24/7, which takes these signals and transforms them with a software interface. You can use it to spell, to communicate, to control the web, to control their home environments. So they can start to execute commands just by thinking. So our piece is just the wearable EEG device that provides those quality signals in a comfortable fashion to the BCI software to do these control tasks.
And as I was reviewing some of your other webinars, that's incredibly more efficient than having to put all of the gel on the head area and in order to put the cap on in order to record the signals. Thank you.
Welcome. Yeah, so for the use case that we're talking about here with NeuroAbilities, the users, usually when we talk about BCI, often a lot of the work is done on graduate students and in graduate schools and research programs. But the end population for a lot of the BCI is a population that has communication or motor disabilities that don't have the ability to speak or move. And so you need to have a device that's easy for their caregivers to put it on them, and a device that can be comfortable for them to wear day in and day out if they're going to use this communication tool daily. And it needs to be practical to clean up afterwards, because you don't want to have to shower the person every time they use their communication device. It's like taking a shower every time you finish using your cell phone.
Yeah, I can see how that's a lot more efficient and um, a lot more practical for home use. I'm going to switch gears slightly and ask you how you got into neurotechnology and the BCI field.
Sure. So how I got into the BCI field was a story of an undergraduate student who realized, as having switched countries, English was not my first language. I was finding it very slow to read and keep up with all the readings I had to do. And I just wished there was a way to download the brain signals into my brain. And I watched the Discovery show on TV, and I saw this scientist at the University of Southern California called Ted Berger, and he was developing computer chips that he was trying to implant to the brain to try to interface with the brain. And that got me really excited. And I see that happening still today with Elon Musk and Facebook proposing really groundbreaking technologies or building on groundbreaking technologies to do exciting things. And those are the building steps that excite people. And then I joined graduate school and realized that there's a lot of science that needs to happen before we get there. But I was still excited about the potential. And then when I finished my postdoc, I decided that I wanted to do something beyond the work in a lab and on animal models and tissue cultures. So I decided to join a company called Quasar that had developed these dry electrode EEGs, which I had learned were sort of the holy grail of what we can do in a brain-computer interface. So I was fortunate that they accepted me there, and I've been able to help develop this technology and develop applications for it.
Thank you. I'm going to retarget the user story element of what wearable sensing does within the BCI world. And I was wondering, inside your company, on a company level, how do you incorporate user stories? We touched on this a little bit earlier, but I wanted to also go into maybe the design process and how these different circumstances for these different users go into the conception process, design process, and then research and development.
Sure. So we rely a lot on feedback from our customers. Unfortunately, today our customers do not necessarily include the end customers of a BCI, but they include researchers who are working with them. And those researchers will come and explain to us their requirements. So one example that I hold dear to heart, because it was my first experience working with a person with a disability, a person who had ALS, is Teresa from the Wadsworth Institute. Teresa Vaughn invited me to go meet one of the customers and to put a headset on this person and see what it was like. And I learned so much in this experience. And I realized that what I learned was how little I knew about this target population. So what we try to do is talk to people like Teresa Vaughn and others in the field who are working with patients, get their feedback. When we deliver products to such researchers, we stay in close contact with them and reach out and say, what is it that isn't working for you? What can we do to modify designs of the headsets? So while we don't necessarily directly interact with the end users, we're working with intermediates who are researchers who are working extensively, not just with one person. So they don't give us the perspective of one user, they give us the perspective of multiple users. And in many cases, what we do is we try to modify our designs for that. And in one case recently, we've been able to put in a proposal to NIH to try to create a custom design for a specific target population, in this case, cerebral palsy, which has really different head morphologies than the normal population. So we need to custom create headsets for this population. So we try to be as responsive as we can when we get feedback from our customers. But we ourselves do not have the direct link.
I did read a really fascinating article that surveyed researchers on who the end user was. And so I learned something in terms of neuroabilities and how it defines the end user as the person with a disability, whereas there are some other definitions of end users, and researchers I learned were within that category as well. So that was really fascinating for me. Thank you, Walid. That's we're going to keep it short today. That's about all our time. I really appreciate your time. You can find out more about wearable sensing at wearablesensing.com, as well as Quasar at quasarusa.com. Stay tuned for more from NeuroAbilities. Our 2021 webinar series is on demand on our NeuroAbilities YouTube channel. You can find us online at neuroabilities.org and on Twitter at G3ACT with the hashtag NeuroAbilities. I would like to thank the IAAP and our colleagues there, as well as our colleagues at the National Center for Adaptive Neurotechnologies and our other partners for NeuroAbilities. And with that, we can go ahead and close off. Thank you very much.
Thank you, Cassandra, and thank you to the NeuroAbilities group. I think it's a really great effort that's bringing us and others in contact so that we can really network and build connections to help move the technology and address the user's needs better. Thank you very much for the opportunity.
Thank you, Walid. It was so nice to see you.
Likewise, thank you, Teresa. And sorry if I butchered. I know I keep forgetting that you guys aren't called the Wadsworth Center now. You're the National Center for Advanced Neurotechnologies. In my mind, it's still the Wadsworth Center.